In the last episode, I asked you to try to rework the friction code using math.min and math.max. If you managed, well done. If not, don't worry, we will go over it now. The main difference between the friction and acceleration code is the target. When we accelerate the player, our target is the maximum allowed speed, while the target for our friction code is 0, since we want the player to stop. When the x velocity is greater than 0, we want to compare the velocity after we have subtracted friction to the target 0. Then we want to pick whichever of those numbers that is greater. To do this, we will set the x velocity to be equal to math.max. Then we will pass in the x velocity minus the friction multiplied by dt as the first argument and 0 as the second. The same thing applies when the x velocity is smaller than 0. Except that we want the smaller number and use math.min. So we will set the x velocity to be equal to math.min and pass in the x velocity plus the friction multiplied by dt as the first argument and 0 as the second. If we run the game, you can see that the friction still works just like before. Currently we have the platforming part, but not much of the game part. Let's add an objective for our player. In most platformer games, there is some kind of a collectible item that rewards the player for taking a more dangerous path or just reaching further in the level. We will add a coin. So far we have created a player, which is kind of a singleton, in that there is only one instance of it. With the coin, we want there to be multiple instances of coins. There are multiple ways to approach this. I will show you how to do it using metatables to emulate a class. Because technically, Lua does not have classes and isn't an object-oriented language like Java, for example. To explain metatables, I have quickly made a new empty project. Let's start by creating a table named person. Inside of the table, I will create a new variable, name, and set it to be equal to Bob. Then I will create a function named displayName. Inside of this function, we will simply print the name of the person. If we wanted to have multiple people with different names, we could create multiple tables, each with the same functions. It's pretty easy to see that this would quickly turn into a nightmare, especially if the table has a lot of functions. Instead, we can use metatables to inherit the functions and properties of our person table to each new instance that we want to create. To do this, we need to first create a table that will serve as the metatable. I will name it metaperson and set it to be equal to curly brackets, just like with a normal table. The difference is that we will add an index inside of the table that will point to the table that we want to inherit from. To set the index, we simply type 2 underscore characters followed by index and set that to be equal to the person table. We can now create a new function which handles creating new people. I will name it person.new and add the name as an argument to it. Each new person needs their own table that will store the specific instance and its properties. To do this, we create a local table which I will name instance. But instead of setting it to be equal to curly brackets, we use the Lua function setMetatable. Sorry to interrupt, previous me said he would make a local table, but didn't. Don't be like him, add the local keyword like this. Okay, let's continue. It takes 2 arguments. First, the child table that will inherit the functionality, and then the meta table that has the information of where the functionality should be inherited from. In this case, we just want a new empty table for the child, and then pass in the meta person table as the meta table. Now we can move on as normal and initiate variables that we want to use. I will create a name variable and set it to be equal to the passed value name. When we are done, we need to return the instance table. Now we can create a couple of test people. We can do that by setting a variable to be equal to the person.new function. I will create 3 different people and pass in different names to them. Then we can call the displayName function on them. Let's go ahead and run the program, and as you can see, each of the instances of people have printed out their own name. When we call displayName on a person, it will first look for that function inside of that table. Then it will realize that it does not exist and checks if the table has a metatable. If it does have a metatable, it will check if that metatable has an index, and then look inside the table or function that the index points to. In this case, it goes into the meta person, gets the person table from the index and looks inside of the person table and finds the display name function. There is a way to do this which, in my opinion, is slightly cleaner. We can have the person table be its own meta table with an index pointing towards itself. We do that by removing the meta person and instead setting the index variable of the person to point to itself. Now we can set the meta table of the instance directly to the person table. Both of these methods accomplish the same thing. I just think it's easier to grasp the concept first when the meta table is its own separate table. Let's use our newfound knowledge with metatables and create a new file named coin. Inside of this file we will create a new table named coin, and then set the index of the coin to point to itself. Now we can create the function that will handle creating new coins. I will name it new and give it two arguments, x and y, which will set the position of the coin. Inside of the function we will create the instance table. Sorry to interrupt again, but previous me managed to forget to make the table local again. Do what I say and not what I do and all that. Alright, previous me, take it away. By setting it to be equal to set meta table and passing in an empty table and the coin table. Next we will set the x and y positions to be equal to the passed in x and y arguments. We want the coins to have an image, so I will create a new variable and name it img, and set it to be equal to love.graphics.newImage. Inside of the parentheses, we will pass in the path and file name of the asset. Next we can go ahead and store the dimensions of the coin into two new variables, width and height, which we will get by calling getWidth and getHeight on the coin image. Finally, we need to remember to return the instance. To test that our code is working so far, we should draw a couple of coins. To do that, we need to first create a draw function. Inside of this function, we will call love.graphics.draw. We will pass in the image, followed by the coordinates. I also want to change the origin point to the center, since we are going to create a physics body for the coin later. To do that, we need to first set the rotation to 0, and the x scale and y scale to 1. Now we can reach the origin offset and pass in half of the width and half of the height. Now we can go into the main.lua file and require the coin file. To test the coin, we will create some temporary instances inside of the load function. I will just name them coin 1, 2, and 3, and set them to be equal to coin.new, with some random x and y values. Finally, we need to call draw on the coins. Remember to do it on each of the coins that we have created. Don't worry, we're going to do this in a much cleaner way soon. All we want to accomplish right now is to see that we are on the right track. If you run the game, you should be able to see that we have some coins spread around the level. Let's clean this up so that we don't need to keep filling our main file with some random variables. Instead of storing each of the coins in a separate variable, we can insert them into a table. For this, I will create a new table named active coins. Inside of the new function, we are going to replace the line that returns the instance with table.insert. This is a function that allows you to insert elements into a table. The first argument is the table that you want to insert into, and the second argument is what you want to insert. In this case, we want to insert the instance into the active coins table. Now we can create a new function named coin.drawAll. This function will make sure that each coin that is inside of the active coins table gets their draw function called. To do this, we need to loop through the active coins table. Previously, we used a simple for loop. We are going to use a slightly different type of loop which looks like this. For I, v in pairs, do. The key difference is that we don't need to manually set the amount of times the loop should run. It will loop until it finds the first occurrence of nil. In order for it to know which table it needs to iterate through, we need to pass in the active coins table. Another very useful part is that we get access to each of the elements as it loops through. It saves it to the variable currently named v. We can name it whatever we want, and to make it slightly more intuitive, I will rename it instance. Now we just need to call the draw function on the instance. To summarize, we loop through each coin inside of the active coins table and tell each coin to draw themselves using their own draw function. We also need to update the coins, so let's create an update function. We will leave it empty for now and create an updateAll function, where we loop through all of the coins and call the update function on them. Now we can clean up the main.lua file by removing all of the old coin code and replacing it with calls to the updateAll and drawAll functions. We can also remove the variables that used to store the coins. All we need to do is call the new function, and it handles storing the coins in the active coins table, which in turn is managed by the drawAll and updateAll functions that make sure that each coin is drawn and updated individually. We have an update function, but we don't update the coins at all. Let's make them feel a bit more alive by making them spin around. We could do this with an animation, but there is also a trick that you can use in order to make sprites appear to be spinning around by altering their scale. Let's create a new function and name it spin. Remember to call it in the update function. Here we will use one of my favorite features with the math library, math.sin. If we print math.sin and pass in the game time, which we can get by using love.timer.getTime, then you can see that it returns a number which goes between -1 and 1. It does this in a sine wave, meaning that it accelerates and slows down as it reaches the endpoints. You might remember that setting the x scale to negative flipped the image. We are going to use this to give the illusion that the coin is spinning. Let's create a new variable named scaleX and set it to be equal to 1. In the spin function, we can set the scaleX variable to be equal to the math.sin function. Now we just need to replace the hard-coded scale value of the coin with the scale variable. When we run the game, you can see that our coins appear to be spinning around. Personally, I dislike that they are synced. To fix this, I will create a new variable named randomTimeOffset and set it to be equal to math.random. This function will return a random number between two numbers. In other words, if we pass in 0 and 100, it will give us a number between 0 and 100. To make it affect the spinning, we will add this variable to the love.timer.getTime call. I also want to speed up the spinning, so I will multiply the time that we get by 2. If we start the game now, you can see that the coins are all spinning faster and out of sync. The next step is to make the player able to pick up coins. To do this, we need to add a physics body to the coins. We will do this in the same way that we did for the player. First, I will create a table named physics. Then we need to create the body and pass in the world and the coordinates. The key difference with the coin is that we don't want them to move, so I will set the type to be static. We could create a circle shape for the coin, but since we can get the dimensions out of the art asset, I will use another rectangle. It's close enough and the small difference is in the player's favor. Finally, we create the fixture and pass in the body and shape. If we run the game now, you can see that the coins have a physical body and that the collisions look good. However, while we don't want the coins to block the player from moving, we still want them to have a collision that triggers the begin contact callback. The key to having both the cake and eating it is to use the setSensor function on the coin fixture and passing in true. A sensor is exactly that, a physical object that can trigger the begin contact and end contact world callbacks while it never causes an actual collision. One final problem remains. The player's begin contact code is going to set the player to be grounded. As you can see, that is causing some unwanted behavior. We can fix this and make the coin disappear at the same time. We do this by creating a begin contact function for the coin. Remember to add the 3 arguments, A, B, and collision. Here we will loop through each coin in the active coins and check if either A or B is a coin. If that is the case, then we need to check if A or B is the player. If it passes through both of these if statements, then we know that a coin and a player have collided. If the player has collided with a coin, it means that the player has not collided with the ground. I know, quite shocking, right? If we know the player collided with a coin, then we can go ahead and skip checking everything else. To accomplish this, we will return the value true. Instead of just calling coin.beginContact in the beginContact function in main.lua, we can create an if statement that checks if the coin's beginContact returns true. And if it does, then we call return, which stops the function from continuing down to the player beginContact. There is a very important thing to keep in mind. You are not allowed to remove or make any changes to the physics world inside of one of the collision callbacks. This is due to the fact that Box2D locks the world. To get around this, we will mark the object and then remove it outside of the callback. I will create a new variable and name it toBeRemoved, and set it to be equal to false. In the beginContact function, we can now set that variable to be true. Now we need a function that checks if the object is to be removed. I will name it checkRemove and call it in the update function. All we need to do is to create an if statement that checks if the coin is to be removed. Next we need to create a function that actually removes a specific coin. I will name it remove. Inside of this function we will loop through all of the coins and check if the current instance is equal to self, meaning the coin that called this function. If that is the case, then we can remove it from the active coins table. We do this using the table.remove function. It takes two arguments. First the table, and secondly the index that we want to remove. Since we are inside of a loop, we have access to the local variable I that is equal to the current index. Remember to call the remove function inside of the checkRemove function. The physical body of the coins is stored inside of the world and does not get deleted even though we remove the coin. To get rid of it, we need to also call destroy on the coin's physics body. If we run the game, you can see that the coins are disappearing. All that remains is having the player actually receive the coins that we pick up. Instead of incrementing a player variable inside of the coin file, we should call a function that handles it. But first, we should create a variable that stores the amount of coins that the player has. Inside of the player's load function, I will create this variable and name it coins. The player should not have any coins at the start, so I will set it to be equal to 0. Now we can create a new function named incrementCoins. Inside of it, I will set the amount of coins to be increased by 1. Let's return to the coin.lua file and go ahead and call the incrementCoins function inside of the remove function. To verify that it works, we can print the player's coins variable. If we run the game, you can see that when we pick up coins, the correct amount of coins that the player has gets printed in the console. We want to give this information to the player in a better way than through the developer console. Let's create a GUI for the player. We should do this in a separate file, which I will name GUI. First, we will create a table named GUI, and then the three base Love2D functions load, update, and draw. Then we need to head over to the main.lua file and require the GUI file. After that, we need to call each of the three functions that we just made in their respective love functions. When it comes to drawing the GUI, we want to make sure that it's drawn outside of the transformations. This is due to the fact that we are going to implement a camera later, and we want the GUI to be static. Next, we will create a new table inside of the GUI that I will name coins. The first variable that we need is the asset that we want to draw. I will name it img and set it to be equal to the same image that we used for the coins. From this image we can get the width and height and store them into variables using the getWidth and getHeight functions. Next we want to store the scale of the image. I want it to be slightly larger than the in-game coins. The reason for this is to make it obvious that it's part of the GUI and not collectible. I will create a new variable named scale and set it to be equal to 3, meaning 300% scale. Finally, let's create two variables that will store the x and y coordinates. I want it to be in the top left corner, so I will set the x to be equal to 50 and the y to also be equal to 50. Let's go ahead and draw it. I will do it in a separate function which I will name displayCoins. Remember to call this function in the draw function. Let's start by drawing the image itself by calling love.graphics.draw. We will pass in the image followed by the x and y coordinates. Next we will pass in 0, because we don't want to rotate the coin. Then we will pass in the scale variable twice, for the x and y scaling of the image. If we run the game, you can see that we are drawing a big, but currently useless coin in the top left corner of the window. In order to make it less useless, we need to display the amount of coins that the player has. To do this, we will use the function love.graphics.print. The main difference between print and love.graphics.print is that print will use the console to display what we passed it, while love.graphics.print will draw it on the game window. The first argument is the string that we want to print. I will concatenate a colon which has a space on each side, with the player's coin variable. Next we need to pass in the x and y positions. We will use the coin's x and y variables. If we run the game, you can see two problems. First, the text appears in the top left corner of the asset, and second, the text is incredibly small. To make the text centered, and on the right side of the coin, we need to add the width of the coin multiplied by its scale to the x position. To the y position, we will add half of the height multiplied by the scale. This line of code is getting very long. We should break out the x and y calculations into local variables, and then use those variables inside of the function. This increases the readability a lot. If we run the game, you can see that the text is printing at a much better position. Though since its origin point is in the top left corner, it's a bit far down. Let's fix that and also increase the size of the text. The default font doesn't really fit our game either, so we will fix that as well. I will create a new variable that will store the font that we want to use. I will name it font and set it to be equal to love.graphics.newFont. We only need to care about the first two arguments. First, we will pass in the file path to the font that we want to use. Next, we will pass in a number that will set the size of the text. I think 36 should do the trick. To apply the font to our text, we need to call love.graphics.setFont and pass in the font that we just created. If we run the game, you can see that it is a lot bigger and has a more suitable font. However, it's still offset. To fix that, we can use the font that we just created to get the height of the text by calling getHeight on the font variable. To raise it by half, we just need to subtract the height of the font divided by 2. If we rerun the game, you can see that the text is now placed exactly where we wanted it. To make the text pop a bit and be easier to read, we will add a small shadow to it. This is really easy. All we need to do is duplicate the line that draws the text. We will set the color to black for the first one, with half opacity. The second will be white and have full opacity. Finally, we need to offset the shadow by a couple of pixels on both the x and y axis. If we run the game now, you can see that the text has a nice shadow. Meanwhile, the coin looks very flat. Let's do the exact same thing for the coin. Duplicate the draw, offset the first one and set it to be black with half opacity. The second will be white with full opacity. This function is a little bit big now and kind of does two different things. Let's break out the text printing code into a new function named displayCoinText. Remember to call this in the draw function. That is it for this episode. Thank you so much for watching. If you found this video helpful, please leave a like and subscribe so you don't miss the next episode. I read all comments, so if you have any questions, don't hesitate to ask.